In lab 10.1, you are going to get experience implementing a ROM array in VHDL. So here is what you are going to do. Okay? You are going to create a ROM array VHDL block. And it is going to be 64 by 8. That means 8 bits is N, that is it's 8 bits wide. So it's going to store a byte of information at a time, a byte of data. You are going to have 64 address locations. That means that you will have 6 address lines coming into it. You are going to have a system, an address counter, which will produce the address to drive the ROM. This is going to be a synchronous ROM, so it will produce data on the edge of a clock. But this block right here is going to store information as follows. You will initialize it with a whole bunch of data that you know exists. So you're going to come in and at address 0, you're going to put 0, 0. At address 1, you're going to put 1, 1. You're going to code this into VHDL. You will then go all the way up to FF and then start going down so that you have 64 address locations, each initialized with data. Then the trick is to read it all out and make sure that it's there. I give you the entity definition for this block. It's going to have a clock, of course. It's going to have 6 bits of address and 8 bits of data out. What you will do is you are going to create this system that looks like this. You are going to use your precision clock divider to get slower or faster frequencies on the clock. You will create this ROM array, and all it's going to do is on the edge of a clock, look at the address, and spit out the data at that location. This 6-bit address counter is nothing more than a counter process that free runs. You will just run from 0 up to 63, 0 up to 63, 0 up to 63. The only trick on this is we want to observe what's in the ROM array. So I would like you to take the 8 bits of your ROM data out. And I would like you to drive it to 2 of the 7-segment decoders and ultimately onto 2 of the hex displays. So you're going to observe what comes out of the ROM on hex 0 and hex 1. You also want to look at what the address is because you want to make sure that you're looking at the right address. So you will look at the address, which is 6 bits, on hex 5 and hex 4. You'll still use 2 7-segment decoders, but since it's only 6 bits, you'll have to go ahead and concatenate a couple zeros on it to make sure you can drive 4 and 4 into the decoders. You'll turn off hex 2 and hex 3 just to get them out of the way. And what you'll do is when you run this, you will see the following. You will see over here your address. Now it's going to be in hex. That's not a big deal. And you're going to see over here your data coming out of your ROM. And it will just cycle. You want it to go faster? Go ahead and turn the select lines up to a faster clock frequency that drives your precision clock divider. Okay? You hit reset. It's not going to reset your ROM, but it will absolutely reset your counter, your address counter. So this will get you to go back to 0. You're just going to be able to observe this and make sure that it goes through all of the possible information in your ROM. Of course, we would like to see this with an analog discovery so that we can actually verify it running at its full speed. And so what you're going to do is go ahead and take your ROM data out and also drive it to the 8 pins of the analog discovery. And then go ahead and take the address and drive it to the analog discovery, or the analog discovery through the GPIO1. Notice this picture right here. I draw where the ground is. So you have D0, D1, D2. Those are the pins of GPIO1. They go up from 0 to 7. That's going to be ROM data out. Then you go D8, D9, D10, D11, D12, D13, D14. Those are the 6 bits of your address. So you're going to observe those guys on the analog discovery using a logic analyzer measurement. So what your demonstration will be is after you go through all this, and I give you the entities that I'd like you to follow, your analog discovery measurement is going to look very similar to this. You will be able to look at the address going in, and you could look at it in hex or decimal, and you're going to look at the ROM data out. So you'll actually be able to see the information that you put into your ROM in VHDL compiling out. Okay? So that's going to be the first deliverable. So that'll be deliverable number 2. And then what you're going to do, or excuse me, that's deliverable number 1 is a video of the 7-segment displays cranking through. Obviously, you got to slow it down to 10 hertz or 1 hertz. And then deliverable 2 will be your analog discovery measurement of it. Okay? And then your third deliverable is just uploading your top.vht. That is lab 10.1.